So, yeah. Hi, I'm Lewis. I'm going to be talking about scalability in Kubernetes today. If you want to get a hold of me and tell me how bad I did yesterday, then you can visit my Twitter handle there. We're going to do some live demos today, hence the song that we had on before, because if you're going to be dumb, you better be tough. So let's get started. There we go. So here's an agenda of what we're going to go through in the next hour. I'm going to just give a bit more of an introduction to about myself. I'm going to show you the application that we're going to be doing a live demo of. Then we'll talk about scalability, and we'll then focus on the live demo. At the end of it, then, I'll give some tips. I'm pretty new to Kubernetes. Well, I've been doing it now for about 2 years, and I was just going to share the things which I wish I knew 2 years ago, which I had to find out myself. So please take photos. If there's anything on the slides that you want to take home with you, then please take a photo. I'll make the slides available at the end as well. Now, I've got some of my favorite speakers also take the opportunity to share some things outside of tech at the start of their talks. So for me, one of them is mental health. I've suffered from depression in the past. I still have anxiety. And I'm not an expert about it, but it's just to say that it happens to me. I'm sure it happens to others. And again, I wish I knew in my 20s that I wasn't the only one with it. The other one is climate change. I was talking about Captain Planet briefly yesterday. It's interesting. Data centers produce 2% of the emissions, of global emissions. Different cloud providers use green energy. Some of them don't. So there's a bit.ly link there if you want to learn a bit more about that, because it's quite interesting. So I've been consulting for a while, and I provide workshops, Kubernetes workshops. And I do that with, well, I used to do that with a company called Learn Kubernetes. As of today, I'm now working with a company called JetStack. Thank you. Oh, too kind. The other thing I also do is I run a meetup from Wales. So Wales is in the United Kingdom. There's some stuff happening over there at the moment. I'm actually running a meetup right now this moment. So I'm in 2 places at once. It's amazing. So why Kubernetes? I worked in the industry for about 10 years, and I was consulting. And I got frustrated that I was a dependency. And I was a dependency for about 2 o'clock in the morning when everything failed. And I really like my sleep. So I was looking towards solutions for this. I ended up looking towards containers, and as I'll talk about later on, initially Windows containers weren't really, they were announced 2 years ago, but they weren't great, so I ended up moving across to using them within Linux. But now we're seeing a shift back to Windows, so we'll come to that later on. But let's start with the application that we're going to be doing. If you look at container projects, containers are great because you don't have to be worried about what runs inside them. So when you start to try and use demo examples and such, you'll find that they've got Ruby, they've got Java, they've got .NET, they've got this and that, and I don't know all of them. I know .NET. So the application that we got here today is all written in .NET Core. I'm looking to update it to be running in .NET as well, with Kubernetes now supporting Windows, and to show that as an example. But all of this is also available on my GitHub page. So all the code that you see today, you can use and download yourself, and then you can play about with, look at all my bugs, and please help out with any pull requests that you like. If you go on, there I am. If you go on there, then you'll see the repos that have the code. So the application, get ready for it. I hope some of you saw Amy and Lemon's talk about CSS. This is my ability of CSS. So I've got a button, and it's a ticketing website. So when you go onto this website, I only want you to do one action, which is to click on Get Ticket. When you click on to get a ticket, then you're taken to a processing screen. Now, this processing screen is going to show a terminal. What you've done is that you've sent a ticket to a message queue. Now, the message queue is being watched by a number of workers. The workers, for some reason, take 5 seconds. I might have a sleep for 5 seconds in there. That might be what it is. But after 5 seconds, it's going to take you to a video of people applauding, because whenever I give a talk, I rarely get applause. So I thought I'm going to force it today. So without further ado, let's have a quick sneak peek at it. There we go. So here's our website. Let's hope this works. So I click on Get Ticket. Signal R's there. That doesn't look like it's working just yet. Oh, demo gods. And just when it works, there we go. I should just be patient, always be patient. There we go, that looks a little bit better. So we can see that it's processing, a new challenger is approached. Okay, We didn't want to boo, really, and I don't want you to see any suggested videos. And please don't look too much into what I've previously been. Yeah, it's their algorithms. They don't know me that well. Let's have a quick look. So let's see what's happening there. So I'm going to do kubectl edit deployments. So I hope you can all see this okay. Within Kubernetes, we use deployments to say what we want to run. This is YAML, and what we'll find is that, oh, here's our image that we're running. So I've got ticketing worker, but I've got the boo tag, not the yay tag, which that's how I do my versioning. So I'm just going to update that to yay. I'm going to save that and quit it. So let's clear that, and we'll just see get pods, and we're going to watch just to see that we got some pods created. So we can see that one's, okay, one's been creating, one's running. So if I now do that command again, but without the watch, okay, one's still terminating, but one's running. So if we go back to the website, hopefully we'll get a bit of a better response. There we go. So our application's working. In the UK, we go to the pub about now. But I'm going to talk about scalability and robustness. Now, things happen. Things get released, and we all want to get the nice, new, shiny thing, which usually means that we get spikes in our internet traffic. Now, from the UK, we're about 6 hours ahead of you here, so it usually happens in the afternoon for us, whereas I think it happens in the morning for you. But how do we manage with these spikes? So how do you deal with so much of this traffic? Well, the solution is usually to have a backend and a front end. So we'll have a backend REST API, and then we could have a website. We could also have apps, because we like apps. And all of these could connect onto the backend REST API. So let's plan for launch. So there's our user, and they go to the website, and it has one backend. So we wanted to scale them out, so we have 4 backends, because I think the US Marines say 1 is none, 2 is 1. So we want to scale that bit out. So, and for us to be able to share the traffic across that, we'll put something in place which we'd call a load balancer. But as well, we'd also, for our website, we'd create multiple instances of it and put another load balancer on top of that. Let's try and do some performance tests. So our web application has a limit of 1,000 requests. Our backend has a limit of 250 requests. So that means that we got a ratio of 1 to 4. So let's get ready. So we got to this point in the day now, and we're going to send some traffic to our website. So the load's coming in, but because we've got a one-to-one relationship there between our website and our backend, then one of the backends can't handle all that traffic. So all of a sudden, we've gone from having 4 to 3, and then the other one can't handle the traffic. The next, and it's all starting to go offline. By this point, you've got someone with a job title starting with C something O, starting to contact you then, saying the website's gone down, so you, after you've made your coffee, you go back to your desk, and then you scale it up. So now we've got 8 backends, and all of a sudden, we can handle all the traffic again. But there's one fundamental issue with that. It's too little and it's too late. We've lost a lot of time and potentially lots of sales. So now let's do a little bit of chaos engineering with this, and we'll just add more users. And so actually, one of the websites have gone, oh no, all the websites have gone down now. But some of the traffic's still coming through, and the backend's just, it's game over. We're not managing this well enough. We're reacting to it, but it's dependent on ourselves. Now, it is a nice story that I'm sharing, but we all know that there's lots of cloud vendors out there who will tell you that they can manage this themselves. Amazon's own website crashed on their biggest day. They knew the date when it was going to happen, but it still went down. And it was quite a lot of people who knew about it. So they didn't have enough service to handle for the traffic surge for the day. Amazon had to manually add servers to address the issue, and they failed to add them fast enough. So what could you improve? How about automatic scaling? So instead of it being dependent on you being at your desk and then finding out your stats, how about if something else can monitor those stats for you? Also, can we decouple the scaling? So we saw that our web front-end application, it was a 1:4 ratio with a backend. So could we scale the backend separate to the front end? So there's our ratio. If we add another website on, then we could just add another 4 APIs. But then we improve the performance that we have available in our backend, and then we now can use a ratio of 1:2, and we can continue to manage that. Also, could we decouple failures? So if we have a document going in via the website, so it gets to the website, and it gets processed, that's great. Good times. Now, if we go to process a document, but none of the backends are available, it goes to the website, and then it would just die a death. Or we could just queue them up there. But what if instead we used a message broker? So we have our user, they go to the website, and they start creating some documents, and we fill them up onto the message broker, and then we can pass it through to the backend. So we can now scale independently. We can add more backend resources, and they can listen to the same message queue. And essentially, we can start now handling the failures. So even if a backend isn't available, we can still load up the message queue. What about automatic scaling? There are a number of options available to us. We've got Mesos, ECS, we've got Kubernetes. As you probably were made aware by the title of my talk, we're going to be discussing Kubernetes today. Reasons for this? Well, it's open source. There's lots of contributions happening to it now, and it's gaining lots of momentum. It's multi-cloud, so it's an abstraction on top of cloud providers. So we don't need to know about the special source that each of the cloud providers do to manage their instances. We can just learn Kubernetes. And it's designed to scale. So we can scale independently, we can handle failures, and we've got automatic scaling. So that sounds like a plan to me. I think that's what we're going to go towards. Now, Kubernetes is an orchestrator. It orchestrates containers. Kubernetes won't solve all your problems. I would suggest focusing on your containers first. That's where you can get the biggest wins. So for an example of our container, we have a .NET application. We have some assets in there. We can put whatever we want in a container, really. We could even have a cat for all I care. Because all I'm interested in is being able to run this container. I don't need to know what's happening inside it. I just need to know how to run it. So let's look at deploying apps into Kubernetes. This is an example of what I've got running for the live demo. So I've got a front-end application, and I've got a back-end. Now, those look a bit like the load balancers that I talked about earlier on. Within Kubernetes, we'd call them services at that layer when it's going onto the pods. I've also got a message queue, and I have a service for that. And then I have a worker, and the worker is now part of an autoscaling group. So today, we're going to use horizontal pod autoscaling as an example of how it's going to work. Lessons learned in scaling with Kubernetes. This is what it looks like, our compute. So this could be bare metal servers, or this could be virtual machines. Each of your worker nodes would require to have a binary install called kubelet. So kubelet is what's listening to, well, what's communicating with your Kubernetes master, and to find out if it's got any work to do. Kubelet would then find if it does have work to do, it'd communicate to the Docker daemon running on that node. So as it finds out that it has containers to run, it would fill up those nodes. Once we got to the state of having 3 full nodes, the solution to this would just be to add more nodes to it. And we can start filling them up too. But not all containers are the same shape or size. So this time I'm showing you the master node. So master node by standard is just focusing purely on the control plane of Kubernetes. So that's delegating out the work. So the other two nodes there are our worker nodes. So when we have a container come through, it would delegate the best node to put it into. When another container comes available, then it'll delegate again. So then all of a sudden we start to find out that it's actually one of the best Tetris players we've ever had. And it allocate as much of the resource as possible so we get the most out of our machines, out of the compute that we're paying for. The other benefit with Kubernetes is it's just a REST API. So it has its own Swagger documentation. So you could interact with this on an API level yourself. You could build your own clients to do things if you wanted to. You can extend it. You can build your own controllers. You can build whatever you want with it. Right. So it's demo time. So having the opportunity of having you all in this room, I thought it would be best that instead of me just doing the live demo myself, I'd ask all of you to join in. So if you could go to developmentsquad.com on your phone or on your laptops, and we're going to, again, I like breaking things, so please could you put your phones on as loud as possible and your laptops on as loud as possible. So we got one there. So we should start hearing some cheers, hopefully. Developmentsquad.com. So, congratulations. We've got a bit of an issue here, though. Because I've got that sleep waiting for 5 seconds, we're just queuing up our message queue. And we're only getting one set of cheers. And this isn't really the euphoric ending that I wanted to my talk. I'd have much rather it if everyone was screaming and cheering. And actually, it doesn't seem too good right now because only 2 have happened. Meh. So let's look how we can change this. So again, if I do kubectl get pods, I can see all my pods running. And I can see I've got a ticketing worker. Thank you again. This is when we start hearing the cheers whilst I carry on. You get used to this after a couple of minutes, I promise you. We can see we've got one ticketing worker. And also, you can see that it's got 2 of 2 ready. Now, within Kubernetes, we don't call it containers, we call them pods. We'll see. I think that was 5 seconds. We call them pods. Now, pods don't have to have a single container running within them. You could have multiple containers running in there. Just think of it as having a virtual machine. The only thing that you need to be aware of is that you can't expose on the same port. So if you had 2 containers running in there, both trying to share something on port 3000, it's not going to work. So the 2 that I've got running within Ticket Worker, I've got one which is the worker process, which is just a console application. The other one is an API. Now, that API is connected to our message queue, and then it'll give us an output just to show how many tickets we got remaining in the queue. So at this point, let me clear my screen. We're going to do a load test because there's lots of us here, but we're going to try and prep it and warm it up. So I'm going to do an A/B test, but instead I'm going to do it for 200. I think I've typed that all right. There we go. So this is Grafana. Grafana is connected to our Prometheus. So Prometheus is scraping the data. And we can start to see that the load test is going through and is picking up. With Prometheus, when it comes out of the box, it'll just get regular stats. So it'll get stats off your nodes that you'd expect and off your containers, such as CPU usage and whatnot. The other thing that we can do with Prometheus is that we can create our own custom endpoints as well, so that we can share our own data. So I could connect this to the API that I'm running within the worker, so we can actually see from that Kubernetes can see how many tickets we got in a message queue. So we can see that graph up there, and again, my time management isn't great. I don't know if I'm going to last for a whole hour here, so we could just watch this go down every 5 seconds, but I don't think anyone would want that. So let's have a look at something else. Let's have a look at our ticketing queue. Now we've got a file here. Let's see if it'll fit in the screen. There. Cool. So this is my YAML for my horizontal pod autoscaler. Now when I pass this into Kubernetes, what it's going to do is it's going to realize that the minimum amount of replicas that I want running at any one moment in time will be 10. And the most that I want running, 20. And I want to see that I have a target average of 3. So let's pass that into Kubernetes now. Just clear that screen, kubectl, apply, -file, HK. So it's worked, it's great. So if I have a look at my pods, I can still see that there's only one ticketing worker on there at the moment. Now, the reason for this is it takes 30 seconds for it to find the update. When it does recognize that I've now got a HPA in place, it's going to update my deployments to having, instead of a single ticketing worker, it's going to set it to 10 to be the minimum, which I'm hoping will happen anytime when I turn my back. There we go. It's only set to our minimum at the moment because the way that the autoscaling will happen is it'll start monitoring the queue, and then it's after, I believe it's going to be a 3-minute period, it'll update to 20. Now, instead of leaving a screen here, what we'll do is, no, I'm on the wrong. So we can see that with a single worker, we're steadily going through and we're starting to take down the tickets. Now that we've got 10 available, we should see some more data points coming online, and we should see that declining at a faster rate, hopefully live demos. Now, I've got about 3 minutes of filler here, so let's try and do that. So why have I got 3 minutes of filler? Well, because I'm using AKS to do this. I love Azure, but I was speaking to the AKS team out here, and at the moment, I've got no loyalties. I just want to go to whatever the cheapest service is or whoever can give me the most credits for free. But when it's hosted, the beauty with AKS, with Azure, is that they pay for your master node. So when I showed you the nodes earlier on, and one with the Kubernetes logo on the master node, Microsoft cover that bill for you. You don't have to pay for that virtual machine. Now, the other worker nodes, you've got to pay for. So those nodes are virtual machines. You're paying for the virtual machine's uptime. What you can do is that when you're not developing with it, you can turn them off. And when you turn them off, you're not paying for them. And so all of a sudden, you can have a Kubernetes cluster that you can develop on, and you can turn it off when you're not using it. So that's why I use AKS at the moment. And yeah, and so we can start seeing that the pods are doing they're starting to work through that workload. There. But let's have a look. So let's see how we're doing with the number of pods that we have. So if I do kubectl get deployments, I can see that ticketing worker has been set to a desired state of 10, and currently 10 are available and up to date. So I'll put a watch on that because hopefully I'll go up to 20 in a moment. Now we're declaring the state to Kubernetes. That's the only thing that happens when you ask people to turn on their phones on nowadays, that you get phone calls, but that's fine. We're all cool. Yes, we're declaring the state with Kubernetes. So what might happen over time is that we might have a node drop off, or containers will come and go. And that's great, and that's what we expect to happen. And this is all just about chaos engineering. I want Kubernetes just to know what my desired state is. This is what I want my application to be like. And that's why that's why I get to stay in bed at 2 o'clock in the morning. Now, focus on your monitoring and your logging, because then your pods will restart, your workload should carry on. You're still going to have to wake up occasionally at 2 o'clock in the morning, I guess. But the main thing is that we've got I feel that we have a fighting chance with Kubernetes to be able to manage our structure. So, again, live demo times and the fears. Let's just have a quick look. Oh, we've got a message queue down to there. Let me just put a few more messages in, or a few more tickets. Testing. Okay. So whilst that's going on, then I'm going to just go back to my slides for a sec. And I've put my clicker somewhere, and I don't know where. So tips. I like to give tips. It was only 2 years ago that I went to my first conference. I never thought I'd get into public speaking. I had no desire to. I just wanted to try and find a community that I could work with. My career path has been very weird, and that's for another story over another beer. But these are off-the-record tips. These are things that no one that I've worked with would share, and it's just me being completely honest. And this is what I'd like to share with you if you'd be interested in working with Kubernetes. So, yeah, I mentioned earlier on about when I got started with Kubernetes, started with containers, it was always Linux, and I didn't know Linux, I only knew Windows. I started off as a developer, I ended up as a Windows dev, and I ended up doing C#. Now, I didn't start becoming a developer because I wanted to learn C#, I became a developer because I wanted to learn how to solve problems. Now, I would go to a well-known search engine and I would try and find material to be able to understand how to use containers. Now, I've got a wealth of knowledge within Windows, but I don't have any knowledge within Linux. But there's a great book that I found, and it's by a chap called Elton Stillman called Docker on Windows. Now, he's just released the second edition. So this was the first edition. It was released in 2016. The second edition now, it's got examples with Windows Server 2019. I'd recommend, if you're looking at running containers, to read this book. It's got some great examples, and it'll be able to get up and running with your containers. But nowadays, Microsoft loves Linux. So I mentioned Azure a couple of times. They have, Brandon Burns is currently working on the Azure team. Brandon Burns is one of the founders of Kubernetes. We've seen with MS Build, there's so much progress now within Microsoft, and it's phenomenal, and the rate of change that's happening there is great. And it's just, well, I feel that as a community, it's just pushing in the right direction. They also have Helm, which is now acquired by Microsoft, but there's some other parts. So anyway, there's a good friend, Sam Newman. He will forever tell me that you don't have to use Kubernetes, and I completely agree with that. Kubernetes shouldn't be a selling point about what's great about your product. Kubernetes should be the hidden thing doing all the work for you. When I run workshops and speaking to the teams, you're looking at occasionally like guesstimating at about 25% of your team might have to manage Kubernetes if you're doing it on bare metal. So it might not solve your problem. If you're just hosting your own blog site, I don't host my blog site on Kubernetes. That would just be way too much. So you don't always have to use it. But this is from my PubConf talk last night. So conference bingo here. Always seeing containers showing like this, which is cool. I understand the concept. We don't care what's inside the container. That's why Amazon ship their parcels all in the same box, because it fits into their nodes being their delivery trucks. But Mr. Meeseeks is the perfect example of what a container should be. And a container should have one job to do, and it should be able to do it well, and it should be able to die gracefully. So on that point, when I start developing my applications now, the first thing I focus on is how will it stop? So you can manage that with SIG-term requests. So when a container is stopped, you can manage it within your code base to be able to capture that and stop the process gracefully rather than just kill it. There's the CNCF as well. So the CNCF of the Cloud Native Computing Foundation. Now, they've got a great website, which is called landscape.cncf.io, but you can just use l.cncf.io. And what that shows you is it shows you all the products currently available within the CNCF. Whenever you hear the latest new thing within Kubernetes, so for example, if you've heard about Istio, you can go in on there, then you can find Istio. You can find out also other products that are available that isn't Istio, but in the same region, to be able to decide what you should be using. Now, the other really useful tool that you can get from this website is if you, just underneath the heading of a website, you can click on the Trail Map. Now, this Trail Map was created to show you how to become cloud native. So you start on point one being containerization. So again, that's the most important part, is if you get your containers managed correctly, then everything should work through quite well. Then you've got CI/CD, and then you've got orchestrator at point 3. So to get the most basic setup to be cloud native, it would be to get to the orchestrator level. Anything after that is a bonus. There's a great term as well that I've recently learned, which is called learn back. So when I got started with some of these, I'd have to install lots of different things, and there's so many steps that I could fail at when trying to get up and running with a new like with a new language or trying out a new product. But there's a website called Katacoda. Has anyone used Katacoda before in here? Cool, so we got a couple, great. It's run by a chap called Ben Hull. He's been really supportive within my career and within the community that we've set up. You can go on there, onto the website. There's lots of different scenarios. Again, Istio as an example, or Envoy proxy, there's scenarios which you can start straight away, and it connects onto a virtual machine elsewhere via the web browser. So you don't have to install anything. You just connect via the web browser, and then you get to learn back. Finally, learn simple things the hard way. There's a couple of great books, and I knew some of Bash, but there's a book called Learn Bash the Hard Way by Ian Mehill. It shows you all the quick tips just to be able to use Bash. Now, I must admit I've used frameworks occasionally to be able to do really simple tasks, but then I'm using a framework and then that takes lots of space. Stuff like Bash, it just helps be able to manage these processes. If you are interested in getting the book, if you get it from here, because that's the best price for it, but it's a digital book as well. I think this is the final tip I would give on this, is create your own private cloud. I've created my own private cloud on Raspberry Pis. So I've got 6 Raspberry Pis, I've got 1 as a master, and I've got 5 work nodes. On that, I'm running websites, I've got serverless functions running on there, and I've a number of different containers and whatnot. But it was a great way to be able to start getting experience as to what Kubernetes was at home and being able to do my own chaos engineering, so ripping power out and such. Now, what's next within Kubernetes? Kubernetes now, as of Kubernetes 1.14, it's now supporting Windows nodes. And I think there's going to be a big shift now into people picking up Kubernetes from our Windows background. To that, does anyone know what the Strangler Pattern is? Okay, we got a couple, cool. So Strangler Pattern is based on the Strangler fig, which is it's a plant that lands on a tree. As soon as that plant lands on the tree, it'll start to grow roots down. When the roots grow down to the bottom of the base of a tree, then it starts to take all the nutrients away from the tree. Eventually, you'll end up with a host tree dying, and then you'd have a tree with a hollow center. So why am I talking about trees? We could do this with our applications. So if you're running a monolith at this moment in time, there's no reason why you can't stick that in a container. Once you've done that, you could use a load balancer above that to be able to direct traffic to a new container. So you could be creating a new website in another container for your application form, for example. And then that load balancer could say that anything that goes to apply goes to this new container with this new code base. This means that you don't have to change anything within the legacy application. So if you've ever, personally, from when I've had to try and do change monolithic code, part of it fails, but I don't know where it's failed. Doing something like this means that I don't have to change anything within that monolith, and I can start looking at building up the microservices until the point where I can just move everything across into a modern approach. So again, I'll just say about Cloud Native Rails, the reason I'm saying this is that this is the thing that's caused me to accelerate so much more in my career, and it's by giving back to the community where I'm from. I was attending conferences in London and around Europe. It's my first time coming to America, but it's helping other people out. I didn't know most about Kubernetes 2 years ago, but what I could do is that I knew how to manage a house party. So I just created a house party, and we got lots of people coming. So right now, there's a house party happening with 120 people in Cardiff, which is our biggest one yet. Doing that, though, having other people see you help others, it's a good way for other people to help you too. It's had the biggest impact on my career. So finally with this then, I think I've probably talked way too long, and we would have lost. Keep a look at deployment. Yeah, we've gone down to a state of 10 again. All right, I'm just going to force this through. I was hoping that I'd keep it at 20, and then I'd ask all of you to... oh, I'm going to have to delete it, actually. Sorry. Everything goes so well until the end. Live demos, never doing this again. Ticketing, Kubernetes. Can't type now. So if you could go on to developmentsquad.com. And then if you could request a ticket. No, live demos is probably absolutely failing right now. Anyway, well, I'll leave it there. We'll see if we get any noises. I'm never going to do a live demo like this again. It's been novel. Thank you for your time. If you do have any questions, I'll be here to take them. I am, yes. So I'm only using SignalR more as a chat process. So when the workers spin up, they connect on SignalR as well. So you're pretty much just watching a chat screen on that terminal window there. It was only just to show, I'm using the serverless version of it that's just been released. Yeah, but it was only just to show some common patterns that we could use in there. But again, the main thing for this demo was to show that all of it's within .NET Core. So if you want to go and have a look and see how it runs, then it's available to you. Okay, I got a boo, so. Yeah.
Can you explain more about the HPA and what you're scaling on?
Yeah, sure.
Yes,
so within, so the question was, how does the HPA work with the Prometheus metrics? So with Prometheus, you can specify where the metric is. So I can say that there's an endpoint available here on this pod. And if you listen to this, I think it's a /ticket that I have on the API. It gives back the total number of tickets available. And then that's being scraped, as we could see on the Grafana dashboard here. That's the metric that's being scraped there. When the HPA is running, then it's then comparing that to the required state that we'd want, and then because it's not matching the required state, then it'd be spinning up additional pods. The most important thing with your HPA, and possibly with containers anyways, is to know is to focus on the CPU and memory usage within your containers, because Kubernetes will keep adding them in, and then essentially you could wipe out your own node, which is then bad times. But I hope that answers. So the HPA is then connected to the Prometheus endpoint metric. So we give a metric a title. So again, I gave it a title of ticketing, and then Kubernetes then manages that within HPA to be able to pull through that data, and then that's using a desired state to compare with that metric value. Yeah. Great, come back to root. So yes, so we specify that it's coming from a pod and the metric type is of tickets, and we want a target average of 3. And so that's what Kubernetes is using then to manage the number of pods that we're spinning up in response to that.
You don't have to point that Prometheus cluster.
No. Yeah. Cool. Any other questions? I finished a little bit early. I do apologize. It's live demos and never knowing if they're going to work out. And
you had that set to only scale up to 20 then, so
yeah.
not more just...
Yes, and so the tip that I give with HPAs is that because, well, within AKS, because there is a 3-minute delay, then you want to have your minimum to a basis of something that you would allow. So again, it's not, at this moment in time, it isn't instantaneous unless you, if you manage your own cluster or even build your own extension for it, then you can look at rapidly updating them. But within this and within AKS, I overestimate with having 10 workers running at once, and then also the way that it scales up, so it doubles it initially. So if I started with 1, then it'd go to 2, then it'd go to 4, then it'd go to 8. So it's something else that's probably good to be aware of. Yeah. So 3-minute delay is just in when it scales up. So if I put the HPA in place, then you have a 30-second delay for the initial setting up to your min, and then you're looking at around about 3-minute delay at this moment with an AKS, then to be able to scale up. But it's one of the handoffs of using AKS as a managed service compared to running Kubernetes yourself. Cool. Right. Great. Well, thanks for your time, and enjoy the rest of your conference.